Hi, so we're going to be looking at the activity today for equations of tangent lines. This activity is a great introduction and connection from what the students learn about circles and tangent lines in the circles unit into what they're going to be expected to do with them in pre-calculus and especially AP calculus. Writing the equation of a tangent line in AP calculus is a very important concept that students must be able to do. So introducing them to that now and making that connection to them while they are first learning about what a tangent line is and why is it relevant to a circle can really help them make that deep connection that they need in order to retain the information. This activity also allows students to spiral in the information that they have learned throughout the year thus far in geometry so that it's a very good culminating lesson for them to apply all of those skills and keep them fresh in their thoughts. So what I've already done is I have taken the question and read through so that I know O is the center of the circle, defined by x squared plus y squared equals 169. Remembering what the standard form for the equation of a circle is, this equation is letting me know that the center is at 0, 0, and the radius is 13. Therefore, if I want to draw a radius from the center O to a point on the circle P, that distance must be 13. Also, we know that P is a point in the first quadrant where x is equal to 5. So I know that my coordinate pair, the x value is 5. I do not know what the y is, however. And if my x is equal to 5, well, that means the horizontal distance to get to P must be equal to 5. Using this, we should be able to now answer questions 1 through 8. These questions will step the students through piece by piece so that when they get to those final questions, they actually have already found all the information that they need in order to answer those questions. So take a moment, pause the video, work 1 through 8, and when you're ready, come back and let's check our answers. Checking the answers for number 1, determine the coordinates of point P. Well, I already know that x is equal to 5 because they told me that in the stem of my question. I need to figure out y, that vertical distance. In order to do that, knowing that this is a right angle that is formed and my radius is 13, if they know their Pythagorean triples, then they should recognize this as a 5, 12, 13 triple. If they don't, then you may have to take a moment and remind them of Pythagorean theorem in which they can actually solve for that and get the fact that y is indeed equal to 12, making that vertical distance 12. And as soon as I know that information, I substitute that in everywhere that it would apply. Draw OP, that's awesome, we've already done that. Determine that slope. We need to remember that since geometry is now coming before Algebra 1, our students are coming with a different amount of practice than what they have previously come to us with. So they are introduced to things such as slope and equations of lines in middle school. This is a topic they should be familiar with. They are more than likely going to tell you that slope is rise over run. So knowing my rise over run for this, how far up do I go? How far over do I go? Well, that slope then is equal to 12/5. Okay, continuing on to the next portion. And remember I said each piece is giving us a piece to our puzzle when we get to those final few questions. Determine the slope of the line tangent to the circle at point P. So I would like to draw in a tangent line to remind them of what that is, and to remind my students that this tangent line is perpendicular to the radius. That is a theorem that was proven earlier in the circles unit. So knowing that, I should be able to determine the slope. If the slope of the tangent line is perpendicular to OP, I can go back to my unit on parallel and perpendicular lines and remember that the slopes of perpendicular lines are opposite reciprocals. Since the slope of OP is 12/5, this slope of the tangent line must be the opposite reciprocal of that slope. So my M, as they're probably going to label their slope, should be a negative 5/12 for the slope of the tangent line. Now I'm ready to write the equation of that tangent line. So this is where we have found bits and pieces and we're ready to start pulling them together. Most of our students coming from middle school are going to know y is equal to mx plus b, which we can do if we remember that the slope is what we've already found and that b is our y-intercept. I would then need to go determine my y-intercept where the x must be 0 and the y I don't know, and I would need to be able to solve for that. We can do that by plugging in our slope, the fact that x is 0, we can use this 512 that's on the line in order to get what b is equal to and move forward from there. I personally like to make the connection to AP Calculus where they are using the point slope form of the equation of a line. And I think that it's helpful for our students to be able to determine when it is useful to use slope intercept and when it is more useful to use point slope. This may be a form of an equation that you have to remind your students about or possibly even introduce them to, but it is a very simple topic that they should be able to appear. So using point slope, I can substitute in the fact that the point that I'm working with is 512 and the slope that I'm working with is negative 5/12. So y minus my y value, which is 12, equals my slope times x minus the x value. If you would like for your students to distribute that negative 5/12 and get it in slope intercept form, they can. However, it is not necessary as they progress through pre-calculus and AP calculus. So you're more than welcome to ask them to leave it in point slope form. Draw the tangent line at point P. We've got that. Let T be the point where the tangent line intersects the x-axis. So my x-axis is here, and this line is going to continue and intersect that x-axis at some point T. My job now is to determine what the coordinates of T are. To do that, I think it's important that our students remember that if I have intersected the x-axis, my y value must be 0. The x is what I'm trying to determine. So knowing the equation of our line is y minus 12 equals negative 5/12 x minus 5. And knowing that the point T we're searching for has a y value of 0, we can substitute that in. And now we have x as the only variable in our equation, so we are able to now do some rearranging and solve for x to get that x must in fact be equal to 169/5. They wanted the coordinates of T, so those coordinates are going to be an x value of 169/5 and 0. Again, spiraling in information of being able to find multiple things within the stem of one question. To finish this portion, determine another point on the circle that has a tangent line that is parallel to PT. In order for an equation to be, for a line to be parallel, they need to remember that those slopes must be the same. So for my slopes to be the same, I know that I have to have the same rise over run. My rise was 12/5 because it didn't say parallel to the tangent line, it said parallel to the tangent line, but another point on the circle. So that's why I'm using the slope 12/5 here. So in order for me to do that, my coordinate point would need to be -5, -12, so that my rise over run is still 12/5. And that is the first portion of our lesson. So what we will do now is, again, you can pause the video, take a moment to work questions 9 through 15, and then come back to verify your answers. So you're ready to check your answers for 9 through 15. Let's take a look at the question. The figure shows a line with a circle and the equations y is equal to x plus 1, x squared plus y squared is equal to 25. We are told that O is the origin, P is a point of intersection, and Q is a point of intersection. Using this information, determine only the x coordinates for those points of intersection. Our students are coming to us from 8th grade now, and what we do need to remember is that although they have not done Algebra 1, they are familiar with what a system of equations is and how to solve it. We might need to help them remember that for this particular setup, the easiest way to solve this system is to use a form of substitution. Because of the length of this work, I've done it on a separate sheet of paper. We are given these equations, so we know that y is equal to x plus 1. Using substitution, we can now work with an equation that only has one variable. Multiplying out the binomial, again, this skill may be something that you have to review with your students, but they should be familiar with. We obtain x squared plus 2x plus 1 is equal to 25. Moving the 25 over, combining like terms, and dividing everything by 2 to obtain a simpler equation to factor, we are able to now factor that and solve for the fact that x must be equal to -4 and x must be equal to 3. So our two x coordinate points are x is equal to 3 and x is equal to -4. The 3 must go here, the -4 must go here. Continuing on, we are now asked to determine the points of P and Q. Well, we know that y is equal to x plus 1. So if my x is 3, 3 plus 1 is 4. If my Q has an x value of -4, -4 plus 1 is -3. Determine the slope of OP, not the slope of this line, but the slope of the segment that runs from O to P, again relying on the fact that the horizontal distance must be 3, the vertical distance must be 4. So in order for this to have a 3 and a 4 for our vertical distance and our horizontal distance, our slope being what they will call rise over run, we should obtain a slope of 4/3. Again, we're stepping out piece by piece so that when we get to the end, we have all the information that we need. Determine the slope of the line tangent to that circle. Again, tangent line means that I am perpendicular to the radius. If I'm perpendicular to that radius, this slope was 4/3. That means the perpendicular slope must be -3/4. Now that we have all of our information, we are ready to write the equation of our tangent line at point P. So point P has the points 3 and 4, and my slope of the tangent line we figured out was -3/4. So I am now able to write the equation of that tangent line. Again, you can ask them to distribute that, or you can ask them not to. Okay, so now we're going to look at number 15 and see that the question is asking us, is the line tangent to the circle at point Q? So this line that touches the circle only at point Q, is this line in fact parallel to the line tangent at point P? So this line here, where it is only touching the circle at one place, point P. So most of my students are going to look at this and say, well, they look like they're parallel, so they are. But we need to actually justify our answer. And justifying their answer is an important skill that we're asking them to develop this year in geometry through the use of proofs and being able to back up what they are claiming as true or not true. Justifying your answer is an important skill in free response questions for AP Statistics and AP Calculus. So it is a skill that we need to get our students used to writing out their answers and backing up their claims with mathematical information. I ask my students, what is this question really telling you to do? If they want to know that the two lines are parallel, I need to figure out, do they have the same slope? Well, the slope of the tangent line at P, we've actually already determined here as -3/4. The slope of the tangent line at Q, I do not know yet, but I do know the coordinates of point Q are -4 and -3. So if I plot that and consider the line segment OQ, I'm able to use those coordinates to determine that the slope of OQ is 3/4. If the slope of OQ is 3/4 and this line is tangent to OQ, which is a radius, then I should remember that those slopes are perpendicular. Those two lines are perpendicular. Therefore, if this slope is 3/4, the slope of the tangent line has to be the opposite reciprocal of that, which is -4/3. Because these two slopes are not equal, the two tangent lines are not parallel. Very close, but not exactly parallel. So this lesson has been a good example of allowing students to recall and apply previously learned information throughout various mathematical courses, while also showing them and pushing them towards what the advanced courses that they will soon be taking are going to require them to do.